The focus of this lesson is on solving exponential equations that are quadratic in form. So you would start off by rewriting it so that it looked and appeared to be quadratic, and then you would use u-substitution to help you solve, and so you would solve for your u, and then after you solve for your u, that would help you solve for your x easily, and then you would want to check your result. So let's take a look at the example we have here. We have 9 to the x equals 6 times 3 to the x plus 8 equals 0. You may not realize it initially that this is quadratic in form, but it is, and it helps if you rewrite 9 to the x as 3 to the second raised to the x power minus 6 times 3 to the x plus 8 equals 0. And then notice you have this 3 to the x raised to the second. You can just change the order of those powers. It doesn't change anything. Minus 6 times 3 to the x plus 8 equals 0. And notice that you have this 3 to the x raised to the second, and then this is 3 to the x raised to the first, technically, even though there's no number written in there. And so that's quadratic in form. And so the idea of using u-substitution now is let u equal that common piece that's raised to the second and raised to the first power, so that equals the 3 to the x, and rewrite your equation with that u instead of the 3 to the x. So it becomes u raised to the second power minus 6 times u plus 8 equals 0, and you see that you do have a quadratic that you can solve for u. And so you would factor, so what two numbers multiply together to give you 8 but add to negative 6, and the answer would be negative 4 and negative 2. And then you would solve each of your factors by setting it equal to 0. And you would see that you get u is 4 and u is 2. And you don't want to stop there because that's what u equals. So if u equals 4 and u equals 2, that means 3 to the x equals 4 and 3 to the x equals 2. So now that my steps are to go ahead and solve each of those for x. So let's go ahead and do that next. And the way we'll solve this is we already have the exponential isolated. We're going to go ahead and apply natural log to both sides of those equations, but I'm just going to rewrite them here up at the top first. So I'm going to apply the natural log, which allows this power of x to come down using the power rule. So x times the natural log of 3 is natural log of 4. So divide off the natural log of 3, you get natural log of 4 divided by the natural log of 3. So x is approximately 1 in 26 hundredths. Apply natural log to both sides. On this equation, you have natural log of 3 to the x equals the natural log of 2. Use your power rule by pulling that x down in front as a multiplier. You get x natural log of 3 equals natural log of 2. Divide by natural log of 3 on both sides. You get natural log of 2 divided by natural log of 3, which is 63 hundredths, so 0.63. And so your solution set at the end of the day, if you checked it and just made sure, you'd get 1 in 26 hundredths and 63 hundredths.